Hello. So today we are going to look on angles in a Cartesian plane. Okay, so we need to understand how the Cartesian plane looks. So we have got our y-axis, we have got our x-axis. Okay, so here we're going to talk of the angles, how it works here. So we've got 0 there. So let me just pull this. So I've got angle of 0 here. Then here we've got 90. Then here we've got 180. Then here we've got 270. Then that right here is 360. Okay. So, and we've got our central point here. Now, when you're looking at this Cartesian plane, from 0 to 90, we call this the first quadrant. Okay. So first quadrant. And here, this one is our second quadrant. And this one is our third quadrant. And this one is our fourth quadrant. Okay. So we've got first, second, third, and fourth. But now we are all familiar now with the trig functions, which is a cos, okay, cos theta. We've got sine theta. We've got what you call tan theta. Okay. Now I want to understand how they're related here when you look at the Cartesian plane. Okay. Let's just draw something here for you to understand here. So let's draw a triangle. And with this triangle, what you see here is that this point, you can call this point X, Y. Okay. And when you look at this, this is going to be 90 degrees. And going up here, it's Y. So we have got Y there. And going that side here, it's going to be X. Okay. And now we're talking of this one as our theta. And our hypotenuse is R. Okay, so here we already know that how to get R. We say R is equals to R squared is equals to X squared plus Y squared. Now, this is the Pyth that we already know, Pythagoras theorem that we already know that we must use when you're looking for one of the angles. Okay. Now, so we want to know how to get your sine theta, how to get your cos theta using this diagram. We know that if we are looking for the cos theta, it's adjacent over hypotenuse. And what is adjacent over hypotenuse in this case? It's x, what call over r. What about sine theta? Sine theta is opposite over hypotenuse, which is going to be y over r. Then what about our tan theta? It's opposite over adjacent, which is going to be equals to what we call y over x. Okay, so that's what we know. Those are the trig functions that we know. But now let's understand also that when we move from one quadrant to another quadrant, there are changes that you see in the terms of value of our trig functions. Now, for example, here, if we are looking at an angle which is from what we call between 0 and 90, we find that if you punch that in your calculator, for all of these three, you will see that they are all positive. So we can say here all. So I want you to remember this this thing here. All students take coffee. So all students what you call take coffee. Why am I saying this? Because here all of them are positive. If you are to punch here, let's say for example, what called an angle of 60 or angle of 40, we say sine 40, we get positive. We say cos 40, we also get positive. We say tan 40, you get a positive. But when it comes to the second quadrant here, only sine is positive. So only sine is positive, but cos here is negative, and also tan is negative. Okay, so if you have to take an angle that is between 90 to 180, which we can take it, for example, let's take what we call 130. So if we say sine 130, you see that you get a positive. If you say cos 130, you see that you get a negative. And if you say tan 130, you get a negative. Now, what about in the third quadrant? We see that tan is the only what we call trig function that is positive. What about sine? Sine is negative. What about cos? cos is also negative. Now, if you are to punch an angle, any angle between 120, 180 to 270, let's just say 200. So if you say sine 200, you get a negative. If you say cos, what we call 200, you get a negative. If you say tan 200, you get a positive. So that's what you take about. What about in the last quadrant, which is the fourth quadrant? We see that the cos is the only trig function that is positive. What about sine? Sine is negative. What about what we call tan? Tan is also negative. So if you are to have any angle that is what we call above between 270 and 360, we can call that, we can take 300. So if you say sine 300, what you will see there, you see a negative. Then if you say cos what we call 300, you see that is going to be a half. Then if you say tan 300, then you see that is negative. So only the cos, what we call cos, is only positive in the fourth quadrant. Okay, so that's all for understanding how you get your angles, and also understanding which, if ever you are given what call a function, we'll talk about it. You also see where is the angle in. Is it in the first quadrant? Is it in the third quadrant? Is it in the fourth quadrant? Okay. Now, let's try to see how you plot. Let's say you're given, what is it? Values here, and you want to plot the angle. We call that the diagram. So the diagram here, you'll be using Pythagoras theorem to solve for your diagram. So for example, here, let's just plot something here. In the first quadrant, let's say we're given that to draw the diagram in the first quadrant, what we see is that it's gonna be, okay, then we have got another one going down there. Then if you are to draw in the second quadrant, you see, can you put it like this? Then this is what you have in the second quadrant. If you're looking at the fourth quadrant, so you can have something like that. Then if you're looking at the fourth quadrant, then you can have your what called. So what happens now is that when you look at this, you see that that's your 90 there, that's your 90 there, that's your 90 there, that's your 90 there. And now, when you look at this, this is going to be our theta, and this is going to be our theta there. This is going to be also our theta there. This is going to be our theta as well. But now, what about the sides here? You see that here, this one on the side, if you are to look at triangle, the first triangle that in the first quadrant here, this is our y, this is our x, and this is our r. So now when you're looking for anything here, sine theta, you find that all of them, the x is positive, y is also positive. So if you are to look for any what you call any trig function here, they are all positive. But when it comes to here now, this is your x. Okay, let me just remove this. This is your x, this is your y, this is your r. But what you see now is that x is now negative and y is now what we call is positive, remains positive there. Then r is always positive. Now, when you're looking for the sign now, you see that sine theta is going to be equals to y, which is positive, over r. What about cos theta? Cos theta is going to be equals to what we call adjacent. But now, what are we having here? It's going to be negative x over r. What about tan theta? Tan theta is going to be equals to opposite, which is y, over negative x. So that's why the two here are negative, because we are taking the adjacent here, and the adjacent here, you know that negative, what call going this, what call this side, if the left side from the center is the negative side, and here is the positive side. So we can say the positive side here, and here the negative side, and also this one is the negative side of y. Now, let's go on to the third quadrant and see what we have here. What we see is that this is our x already is negative, and this one y also is also negative. So what you will see is that if you had to look for sine theta is going to be equals opposite, which is negative y over r. What about cos theta? It's going to be equals to also negative x over r. And what about tan theta now? Tan theta will have to be negative y over negative x. That will give us a positive. That's why we are saying a tan is positive in the third quadrant. What about in the fourth quadrant? What do we see here? You see that, so here, let's just say here, negative x and also negative y. So this is what we see in the third quadrant. What about in the fourth quadrant here? What we see is that the y now is negative. So here we've got negative y going down, but we have an x going at that side here, and it's positive. Okay. So how do you get your sine theta now? Sine theta is going to be equals to, sine theta is going to be equals opposite, which is negative y over r. What about cos theta? Cos theta is going to be equals to x over r. And you can see now your cos theta is positive. What about tan theta here? Tan theta is equals to a negative y over x. And you can see now your tan is also negative in the fourth quadrant. That's what you need to remember, guys, that this is how you draw your triangle, because they will ask you to draw the triangle to solve what called trig functions using what called the diagram. And this is what you're supposed to draw. This is how you're supposed to draw. So when you're drawing a triangle, a diagram in the second quadrant, this is how you draw it. In the third quadrant, this is how you draw it. In the fourth quadrant, this is how you draw it. So it's simple, because you are going to substitute whatever you see as an opposite, you put it as y. Whatever you see as adjacent, you put it as x. That's it there. Now let's move on to the next question here. Let us attempt something. Now they're saying, in this question here, they're saying sine theta is equals 3 over 5. So sine theta is equals 3 over 5. So here we are saying it's positive. And this here is what called the domain. So domain guides you. So let me just put it in. Domain always guides you. The domain. So this is the domain. So domain guides you. How does it guide you? It guides you to know which quadrant, okay? Which quadrant are we talking about? Okay, which quadrant are we talking about? So if ever you see that here sign is positive, and also the sign here is actually important here. Check if the sign, what call the sign is, it's a positive or it's a negative. It also helps you determine which what call quadrant. Okay, so here, so let's have an example here. Sine theta is equals to 3 over 5, and we are saying the angle is between 0 and 90. So it means that it's in the first quadrant. So you come here and say, okay, how do you plot this? So you come there and say, okay, let me plot this. Let me just plot and remove these values there, so that we just throw something natural here, since we don't have another value here. So let's have 5, 1, 2, 3, 4, 5. Let me just throw something here. So up there. Okay, and let's go down there. Now, so in this case here, you can see that our 90, this is our 90, and here we have got our angle theta there. And this side here, what are we having? We are having 5 here. That's our r. Then we also have the opposite, which is 3. So now we need to look for the x. Why are we saying in the first quadrant? Because it's between 0 to 90. Okay, so now we need to look for the third quadrant. So you remember Pythagoras theorem, guys, you must not forget. So here, what do we know? We know that r squared is equals to, what is it? X squared plus y squared. And here we are looking for the x, which is our adjacent. So adjacent is x, and we're going to say now x squared is going to be equals to r squared minus y squared. So you always subtract the smaller sides from what called the belonging side, which is hypotenuse, when you're looking for any of this side. So here it's going to be x squared is going to be equals to what called 5 squared minus 3 squared, which is going to be what you call 25 minus what you call minus 9, 25 minus 9. So x is going to be equals to root of 25 minus 9, it's 16 here. So here, let's just confirm that 25 minus 9, you get 16 there. So root 16, it's 4. So it means that here it's positive 4. Now, there's another thing again that you need to remember here. Let me just put what you call it's 4. I want to put something here in another color there. Let's have a 4 there. Okay, so now what you need to say now is that once you have all the sides, so the first thing that you need to do is to find all the sides. So steps here, when you're looking for such things, so steps here, what called draw the diagram first. Draw diagram. Okay, number 2, what is it? What called? Or let me just put it. Here, steps. Draw diagram. Number 2, find third side. Using Pyth. Then using Pyth, so for example, we've done the Pyth here, so that's our Pyth there. That's our Pythagoras theorem there. Then the third step there is to write your trig functions, right? Okay. Write down trig. Now, how do you put it now? We need to start with the sine theta there. So sine theta, already we are given, which is 3/5. What about cos theta? Cos theta is adjacent of hypotenuse, which is going to be 4/5. What about tan theta? Tan theta is opposite over adjacent, which is going to be 3/4. So now you have everything that you need now, so you can come and actually answer the questions now. Now, how do you answer the first one here? It's cos squared theta. So already you know that cos squared theta is going to be equals to what is our cos theta there? It's 4/5, and 4/5, you just squaring it. Okay, because cos theta here is 4/5. So once you square that, what do we get there? Let me just put the bracket there, 4/5. What do we get? We square that. What do we get? We get 16/25. So the answer there is 16/25. That's how you get what called what is it? Cos squared theta. Let's look at tan theta. 2 tan theta. What is our tan theta there? Tan theta is equal to 3/4. It's going to be 2 times 3/4. You just write the expression as you have, and this one will give us 3/2. That's it. So that's how you do it. What you call simple as that. Let's move on to the next question here and see if we can tackle it. Now here it's 90. What is it? 90, between 90 and 270. Now we're told that 8 tan. So let's just write that 8 tan theta plus 15 is equals to 0. Now, what you need to do here is that get rid of this and also get rid of the 8. We need to be left with tan theta on its own. So what do we do first? 8 tan theta is equals to negative 15. Then again, we need to get rid of the 8. So we divide by 8 both sides here. We divide by 8. So tan theta is going to be equals to negative 15/8. Now, when you've got negative 15/8, now they're telling you that the angle is between 90 to 70. So here is our 90, remember? Let me just put it here. This is our 90. 90 there. There was 180. This one is 270. This one is 360 and 0 there. So what are they saying here? They're saying the angle is between 90 to 270. And here we can see that tan theta is negative. So where can it be? It can only be in the second quadrant. This is how you tell, because now they tell you that the angle must be between 90 to 270. And again here, your tan theta again, the sign that we have here is a negative. So what do we need to do now? So you can see that this one, let me just circulate it, it's a negative. And when it's a negative, what does it tell us? It tells us that no, it lies in the second quadrant. So in the second quadrant, we can draw our triangle. Now, when we draw a triangle, this is our 90, and what is given to us tan, we know that tan theta is equals opposite of adjacent. So what is our opposite there? Our opposite there is 15. What about our adjacent? It's -8. Because adjacent here, you see that this x is negative in the second quadrant. So here, that's why we have got adjacent here negative. And now we can look for the third side now using Pythagoras. So let's look for the third side, which is our hypotenuse. So our hypotenuse is r. So you know that r squared is going to be equals to 15 squared plus what call -8 squared. We put that in bracket. So what do we get there? Let's say 15 squared plus 8 squared. What do we get? 289. So here is 289. So we say r is going to be equals to root of that, which is going to be, so root answer is 17. So r is equals to 17. So we put our 17 there. We'll put our 17 there. Our 17, now we've got all the three sides. Let's express our trig functions here. Let's start with the sine. So sine theta. So this is our theta there. So sine theta is equals to opposite over adjacent. So it's going to be opposite over hypotenuse. It's going to be 15 over 17. Okay, it's positive there. What about cos theta? Cos theta is equals to what is it? Adjacent over hypotenuse, which is -8 over 17. What about tan theta? Tan theta we're given is what called is tan theta is negative. It's 15 over -8. Okay, so why did I put the negative again there? Okay, so it's like that. Okay, now we can move on to the next step now, answering questions now. How do we answer this now? Let's see. Sine theta plus cos theta, sine theta plus cos theta. We already have the values of sine theta and cos theta. So what is going to be sine theta? 15 over 17 plus what is our cos theta? It's -8 over 17. Okay, now how do we get that? Let's put that in a calculator. So it's just 15 minus 8 here, which is going to give you 7. So here it's going to be 7 over 17. That becomes your answer there. Let's move on to the next one, which is 34 sine. I like using another color so that we can see the difference questions here. Now 34 sine theta minus 17 cos theta. What is 34 sine theta here? 34, what is our sine theta? Sine theta is 15 over 17 minus 17, what call times -8 over 17. Okay, so here we can see that if we take the 17 there, it's gonna give you 2, then the 17 and 17 will cancel, and what's gonna be our value now is gonna be 30 minus what call minus 8. Minus is gonna be plus, so it's gonna be 30 plus 8, which is gonna be equals to what call 38. That's how you get your values. Okay, so let's move on to the next question here. Now, we are told that 5 cos A plus 3 is equals to 180. This is now simple because we have done it before. Now, let's see how we're supposed to do it. We have to come to write our value there. Cos A plus 3 is equals to 0. So we need to get rid of the 3. So 5 cos A is equals to what you call -3. And here, we also see that we divide by 5. We need to get rid of the 5. Cos A is going to be equals to -3 over 5. Now, cos is negative. Now, if cos is negative, it means that it can't be in the first quadrant. But now, what is the angle? We are told that it's from 180 So it's from 180 to 360. So here is 270. So our focus is here. So we are dealing with the third quadrant and fourth quadrant. So where must it be negative? It obviously has to be negative in the third quadrant. So here we know that where are we going to draw our triangle? We're going to draw our triangle in the third quadrant. Okay. So here we can draw our triangle. Okay. Nothing is drawn to scale, guys, here. So this one here is our triangle. And that one becomes our R, which is in this case here our 5, and adjacent here is -3. So you can see that we need to look for the opposite side. Now, how do we get the opposite side? We use the Pythagoras. So here we know that we're looking for the opposite, which is our y. So y squared is going to be equals to our r squared minus what we call x squared. And here y is going to be equals to root of what is our r squared is 5 squared minus what is our what we call what is our x is gonna be what is it, -3. Let's see here. So it's gonna be 5 squared minus what we call 3 squared. What do we get? We get 4. So our answer there should be equals to 4. So here it's going to be -4, because remember here it's always plus minus. When you're looking for the square root, it's plus minus. So now you choose which sign should I put, because you know now that in the third quadrant both your x and y are negative, so that should be also negative. So you consider negative in this case. So I would say this case here we are choosing a -4. So now let's try to express our trig functions now. So we know that sine theta is opposite over adjacent over hypotenuse. So it's going to be -4 over 5. What about cos theta? Cos theta we're given. What about tan theta here? Tan theta is equals to -4 over -3, which is going to be equals to 4 over 3. Cos theta, we just write what we have because we already calculated it. So here is -5. Now, the questions comes now. What are the questions now? Let's look at it. Tan squared A. Okay, so here we just forgot to put our A there, our angle A. So here, let's look at it. Tan squared A. Now, tan squared A is not a problem here because we know tan theta. Tan theta is equals to 4 over 5. We square that. What do we get? 4 over 5. If 4 squared, it's going to be 16 over 25. Now let's go on to the number 2, which is sine A divided by cos A. Now, what is sine A divided by cos A? Let's look at it. It's going to be equal to, what is the sine A? Is -4 over 5 divided by cos A. Cos A is -3 over 5. Okay, so you can put this in a bracket. You don't want a problem. Then now, when you want to multiply this, you actually invert there. It's going to be -4 over 5 times 5 over 3 negative. So here the negative and negative will cancel there. Why are they cancelling? Because we are dividing negative and negative. And here the 5 and 5 also will cancel. And our answer will be 4 over 3. That becomes our answer there. Okay. So I hope you guys are understanding this and we are together. Let's look at this one here where we are saying tan theta, 4 tan theta. Let's try to solve it quickly. 4, use another color there. So we're saying 4 tan B minus 3 is equals to 0. And here 4 tan B, we are removing 3 there. It's going to be +3. Then here we divide both sides by 4. So tan B is equals to 3 over 4. Now we have got 3 over 4, but what guides us now is that which quadrant should we have? We are told that cos B is less than 0, meaning to say cos here is negative. Now, you need to now check, because some will rush and say, okay, I see that tan is positive. I'm going to put it in the first quadrant. It's not in the first quadrant. It's not in the, what you call, in the first quadrant. Why is it not in the first quadrant? Because what we have here, our cos is negative. Now, the cos B is less than 0 means that it's negative. So it means that we need to draw in the right quadrant. And when you draw in the right quadrant, we will get everything that we need. Let's try to see here. So let's have let's have our 90 there. Let's have our R. We don't have our R there. Let's have our X, which is our adjacent. Let's just put this one as our B. Okay, then here it's negative 4, and this one here is negative 3. So now you know that these values are negative. If we were to draw it in the first quadrant, both of these we're going to write them as a positive as they look on the tan. So you need to check the domain. Domain is very much important to check the domain, because it's going to tell you where should you draw your triangle. Okay, now let's see what we're going to do next here. We need to find we need to find the third side, which is R. So R squared is equals to what is it? Negative 4. Negative 4 squared plus negative 3, squared. Do you know that R is going to be root of that, which is 4 squared is 9, which is going to be root of 25. And in this case, you get 5. So root of 5. Now, the hypotenuse is always positive. Hypotenuse is always positive, so there is no need for you to stress them. Now, let's look. Let's put them down now. Let's put the values down now and see what we have. The sine theta, sine B, sorry. We are going to collect here. Sine B is equals to, what is our sine B? Sine B is opposite, so it's negative 3 over 5. What about cos B? Cos B is negative 4 over 5. What about tan B? Tan B, we know that because we have it, is 3 over 4. Now, what do we do next? What we do next here is that to solve the solution now. To have the solution, find the solution of what we have, what we are looking at now is going to say sine B plus cos B, we're squaring that. So what is our sine B? Let's come back to our trigs here. It's negative 3 over 5 plus cos B is what? It's negative, let me just put it this way, negative 4 over 5. We're squaring that. Now, when you put it now in this case here, you're going to say, okay, our bracket here, negative 3 over 5. So let's just calculate this together, man. Negative and negative here, you see that you are adding, so the denominators are the same, so you're just going to add the top, so it's going to be negative 7 over 5, and we are squaring that. When we square that, negative 7, this one, the negative will get rid of the negative because we are squaring, so 7 squared is equal to 49, and 5 squared is 25, so that becomes our answer there. Now, let's look at the third problem there, which is 25 sine B minus cos B squared. What is our sine B there? Sine B is negative 3 over 5. What about cos B? It's minus and minus 4 over 5. Are we squaring that? Yes, we are squaring that. So here, let's look into our, this one, it's more like we are saying 25 and bracket negative, because we have the same base here, negative and negative is going to be plus, so it's negative 3 plus 4 is going to be what called 1. So it's going to be positive 1, so positive 1 over 5, which we'll get there. Then we multiply, we square that, sorry. We square that. It means that is 25 times 1 over 25, which is going to give us 1. Okay, so some of the things I didn't punch in the calculator because They are so obvious. Okay, so I hope you guys you understand on how to solve these kind of problems. So here is the question that you are going to have also as a homework. You can send to me if you are getting it. If you're not getting it, you can also what call find out how it's done. Thank you so much. But also here, just for you to understand the diagram here, the diagram here is PB, meaning to say your P is your X. Always when you're putting coordinates, it's XY. So here it means that it's B, then Y is 18. That's what it means here in this case here. Okay. So thank you so much. Until next time.